All right, I'm going to go and say hello to everybody, and I'm going to share my screen because what we're going to be talking about today is developing with the Windows subsystem for Linux on Windows 10. I know that there's lots of different developers with us today, and there are Windows developers, Mac developers, Linux developers. I'm going to show you how we can all develop for any platform that makes us happy using the Windows subsystem for Linux. So right now, what you should see is my big, bright, happy background here on my Windows 10 machine. And what I'm going to do is I'm going to give you a little bit of a different kind of a keynote, not one that includes slides. We're going to spend some time in Notepad, and then we're going to do lots and lots of demos. So I'm on Windows 10, and I like Windows 10 a lot. And what I'm going to talk to you about are Windows 10, the Windows terminal, which I think is great for developers. I want to talk about WSL, the Windows subsystem for Linux, the subsystem for Linux. And then a little bit briefly, we'll talk about WinGet. And then we'll see how VS, Visual Studio and Visual Studio Code, plug into those things as allowing people to do this kind of work. We'll also see how Docker and containers fits into this, and then how you might connect all of this up to Azure. Sound like fun? I hope so. I'm glad that I'm here virtually. I wish I was there physically. Maybe another time I'll be able to come and spend time with you all. All right, let's talk first about the Windows terminal and why it's important when we think about Windows subsystem for Linux. On Windows, if I type the command prompt, you're used to seeing this. You're used to seeing this big kind of black square, and you can do things like type dir, and it looks kind of like DOS, if you're familiar with DOS. When we run PowerShell, it looks like this, and it's blue, and it's another console application. So we see that we have console applications, and what happens is, as developers, we start using different words and we're not sure the difference. We hear console, terminal, shell. I mentioned DOS or the command prompt. I mentioned PowerShell. If you're a Linux person, you hear about the bash. This can be a little bit confusing. So what is the difference between a terminal, a console, and a shell? And why do I think that we need to think about those things? Well, the shell is the thing here that takes input and gives us some output. So I type some nonsense, it thinks it might be an executable, and it says, I don't recognize that. So that was the command prompt. On Windows, that is cmd.exe. So if I come out here to the Windows Start menu and I type cmd.exe, that's the command prompt. There's lots of different prompts. Now, here's where it gets a little confusing, but I think it's important for us as developers to understand. The command prompt did not paint on the screen here. It did not paint on the screen. When I go and clear this out and I say dir for directory, it gave us some strings, but something else painted on the screen. Just like when I go over here to PowerShell and I look at my directory, PowerShell gave Windows some strings, but it didn't paint to the screen. Why is that interesting? Well, if I click here in PowerShell and I say properties, I get this box. If I click over here in the command prompt and I hit properties, I get that box. Isn't it interesting that these boxes look awfully similar? Who was responsible for drawing this box? Did PowerShell draw that box? Does PowerShell know about fonts and things like that? Well, in fact, it does not. These are created by and managed by something that is called the console host or conhost.exe. And this is really important because the shell, that's command or PowerShell or bash, the shell thinks about strings. It thinks about output. But the console is something else. It's the thing that communicates with the shell. And the term terminal, what does terminal mean, right? Terminal means end of. If something terminates, it's the terminal end of something. And in fact, a terminal in the old days was a typewriter. So if I go here and I search for my blog post that I talked about these things, I actually talk about the difference between a terminal, a console, and a shell, and I call them out because that's what a terminal looks like. That terminal talks to the connected computer, and then that turned into a console. Now, why am I telling you this when we are here to talk about Linux and development? Well, it's important because there are many, many limitations. There are many problems with this console host. For example, if I hit dir/s and I decide to go and just spit out lots and lots of information, here's a horrible thing about Windows. This is a sad thing. If I make this smaller, it will go faster. People who have been working on Windows for many years learned that the less information that your console application spits out, the faster it will go, and it goes slower and slower if it gets bigger. That's because it's painting as fast as it can, but it blocks the application. So that's an architectural problem with the console on Windows. Here's the thing, though. There's so many applications that rely on this. How can we improve it without breaking everything? Well, what we've done in Windows 10 is we've come up with a thing that's called the PTY. It's the pseudo console. I search for pseudo console. I'm not very good at spelling things. Here we go. In 2018, Windows introduced the pseudo console. And what that is it's a new architecture that keeps the shell and the terminal separate and creates a relationship between them. And that would allow us to write a new terminal, which is very exciting. So I'm going to close these old terminals, and then I'm going to go here and I'm going to type in the word terminal, and I want to run the Windows terminal. You can go and download this whenever you want to. You can download it now. The Windows terminal is an entirely rewritten console. Now this is interesting. I'm going to actually bring up the old one and the new one, and I'm going to put them next to each other. So a couple of things show up here. Let's actually put them side by side. And I'm going to zoom in and notice a difference. That looks kind of cool. It's got a nice glyph with an arrow. There's information there. This has a bunch of question marks. It doesn't understand what's going on. So right away, we see that the new terminal is smarter about fonts and what are called glyphs. I can go into one of my code folders using this new Windows terminal. You can see I have an additional glyph here showing me branching in Git. We've got a glyph here showing me that my Git branch is clean, and then we see that we're on the main branch. If I go to a different one over here, we see information like I have a modified file and an added file, and I'm on a dirty branch. I've been able to add those glyphs because it's a very configurable very configurable terminal, but I'm still using the same PowerShell as before. It just comes in a different application. This application also allows me to have tabs, so I can open up different command prompts. I could say, here's the DOS command prompt. We'll talk about WSL in a little bit. I can open up Windows or PowerShell or whatever. In multiple command prompts, I can then move these command prompts around. I can even change their color and rename them to remember things that I'm working on. It's a very completely rewritten, new, advanced shell. And in fact, that is up at GitHub Windows Terminal. Here you go. So you could even build this yourself. You can get involved in open source. So this is a fundamental part of Windows that is being completely rewritten from scratch using modern techniques, which is really exciting. Additionally, I can do things like this. Here I've got PowerShell. I can make this screen transparent, and I could potentially have things behind it. Look, I can put that like this, like a glass. I could even hold down the Alt key. I'm going to hold down Alt with my left thumb here, and I'm going to click on Ubuntu. And notice that I've split my terminal in half here. And I've also got down here in the corner a graphic indicating that this is PowerShell and a graphic indicating that this is Ubuntu. So right away we see that there's lots of different settings. So where are those settings configured? Well, if I click here, I click on Settings, I'm going to launch my JSON editor, which in my case is Visual Studio Code. So settings today in the Windows terminal are managed inside of Visual Studio Code. Here, I'm going to go and split this in half. I'm going to say my terminal on the left, and I'm going to have Visual Studio Code on the right. And I can make settings changes. And I hit save, and you can see immediately on the left, the font size changed. I'll put it back to 16. I'm going to hit Control S with my hotkey, Control S, and you see that that's changed. I can change my font faces to something maybe that isn't this font, like Arial. If I just change my font, you see it immediately changed. Look at my glyphs. They're gone now. So I needed that smarter font. In fact, the Windows terminal comes with a new font called Cascadia Code, and the PL right here means power line, and that gives me glyphs like this that make my prompts prettier if I want to. You can go and search for Hanselman, my last name, pretty prompt, and you'll get an article on that, or you can go to the Microsoft Docs and they'll set you up step by step with a prompt that looks cool. You can see here they've even allowing emoji in your Git commits and in your strings at the command line, which is really, really nice. I want to make sure that we're clear, though, that this is a change to the terminal, not a change to the shell. I can still use the things that make me happy. For example, some people really like to use Git Bash. Git Bash comes with Git, and it looks a little bit like Linux. It's not really, but it's a different shell. You'll see this box that it just created. If I go to the settings here, we can see that this settings box is very different than the one that we saw before. They have changed that, and they've created their own custom console application. But if I don't want to use their application, I don't want to use this black square, but I want to use this shell, not the terminal, but the shell, I can go and make changes to my console, and I can go and create a profile. Here's my Git Bash profile, and here's the command line that we call for that. I can set the icons, the fonts, the colors, whatever makes you happy. You'll notice, of course, when I did my Ubuntu or my Linux profile, I had a custom color scheme right there. So it looked different than the blue one that I got with PowerShell. So it's called Ubuntu Legit. Let's go down and look at that. And you can have named color schemes. And because I'm using Visual Studio Code to change those, I can actually click on these and pick my colors with a color picker. This is a really nice experience. So if I go back here and I open up Ubuntu, I'm going to hold again Alt, and I'm going to say Alt Ubuntu. I've got one color scheme on the left in Windows in PowerShell, and another one on the right in Ubuntu. So this makes me as a developer very happy. I could even click again and then open up the command prompt down here, and now I've got Windows or the DOS command line, and I could have multiple builds going on. I could even go and do something like this. If I said .NET Run on Windows here, I'm going to run my application, and you'll notice in the next version of the Windows terminal, we actually can click on hyperlinks. See how they're underlined? I can click on that, and that will actually launch a browser. So that's a really nice experience, just being able to run something from the command line and then control click on that link. Almost makes the text mode terminal feel a little bit like a browser there. That way I don't have to do what we always do, which is select it, right click, go over here, click and paste, which is quite tedious. Okay, now let's return to Notepad and make sure we understand what's going on. Okay, our terminal paints things and does user input. There's lots of different choices of terminals. There's the Windows terminal. There's the one that comes with Windows called the console host. You might hear about other ones, like there's a really cool terminal called Commander, CMD-ER, which is a nice little terminal application. There's another one that's called ConEmu. There's lots of terminals, both first party and third party. That means both Microsoft and by other people. So lots of terminals. That's a choice you make as a developer. It doesn't matter which one you pick. Pick the one that makes you happy. The console is now the pseudo console, and that's the part inside of Windows that allows us to pick any terminal. And then on the shell side, you can pick lots of different things. Command prompt, that means that should say bash. PowerShell, that is your interaction model. There are other ones, like I think ZSH is one. There's one that's called, I think, the fish shell, which is a funny name for a shell. Pick the shell that makes you happy. These are Windows. People who work on Linux or Mac will use these different shells. So we need the ability on Windows to run Linux applications. So I would like to be able to bring up my terminal and run bash and have it work just like a Linux machine. Now, in the past, I would go on my beefy computer and I would type in HyperV, and I would bring up HyperV and I would create a virtual machine. But virtual machines are quite heavy. They might be 10, 15, even 30 gigabytes. When I start them up, it takes many minutes to fire up a virtual machine. And I'm effectively thinking about a computer inside of a computer. It's a square inside of a square. But if I'm going to do development on a virtual machine, I might as well just get a Linux laptop or get a Mac. What we want to create is the ability to develop for Linux, with Linux, on Linux, without leaving Windows, in a way that is very much integrated into the environment. All right. So what I'm going to do is I'm going to open up Ubuntu, and again, I'm going to hold down Alt to do a split screen. I don't need to do a split screen. If I wanted to, I could just say Ubuntu here, and now I have a tab. So here's my Windows, and there's my Ubuntu. And I want you to notice how quickly that started. Let's do that again. I'll type bash 1000. Took less than a second. Let's try opening it here. 1000. So about a second, not minutes. Is that a virtual machine, though? Well, yes and no. You go to your start menu and you type in Windows Features. You get this dialog box, and in that dialog box, you can select HyperV. But HyperV is not available for all versions of Windows. In fact, it's only available for people who have Windows Pro. So we didn't want to make it so WSL could only be used on Hyper-V. In fact, what you can do is create checkboxes here for the virtual machine platform and the hypervisor platform, and you can ignore the Hyper-V checkbox. This allows us to use WSL, the Windows subsystem for Linux, on any machine, Windows Pro or Windows Home. It's even enabled on the Surface Pro X, which is a low-powered ARM device. But once you've turned that on and then decided that you're going to use the Windows subsystem for Linux right here, that gives you the flexibility to go and run Linux very, very quickly in what is called a utility virtual machine, not a big giant one that uses all of your memory. So what I'm going to do is bring my task manager over, and we're going to go and we're going to say WSL -- shutdown, which is going to turn off and release all of our memory that is being used by WSL. All right, and then we'll go and say bash, here we go, Ubuntu 1000. And then look at this. Here is our little VM memory manager, our little virtual machine memory manager. What if I open lots of different Linuxes? There's lots of different ones here. WLinux, Ubuntu 2004, Kali Linux. I think I had a couple of other ones in here. I've got 4 Linuxes running. You can see that VMM has gotten a little bit larger, but honestly, Teams is using more memory than my 4 different Linuxes, which is kind of funny. And then as I make them smaller and shut them down, we'll slowly see that memory here will go and shrink in about 2 or 3 minutes. And I could then shut down each individual Linux distribution if I wanted to. This does not grow and get big and fill up your machine. It grows and shrinks depending on what you're doing. What's happening inside there is a real Linux machine. If I go here to Ubuntu and I type lsb release -a, you can see that that's really actually Ubuntu 18.04. And if I run something like htop, which is like a task manager, you can see that I've got 20 processors available to me, which is the same number of processors that this computer has. So it's seeing full access to the abilities of this computer. It knows that all 20 processors are there. If I type ls, here's something interesting. I'm on the Linux file system. So I'm in /home/Scott. That is not the same as c:\users Scott, which is the Windows file system. So where is my home directory on Windows? Well, because we're using Linux, I'm going to have to go to the root here. I can go to a mount point, MNT, and you can see I've got a mount point there for each drive on my machine. So I could say, go to C, users, Scott, and let's see if I go to the desktop. There we go. So there is this, okay? Here, I've got my Windows desktop expressed through Linux. So I could create a file here. I could maybe say vim test.txt. This is a Linux file, or really a file from Linux. Save that. Come over here. See if that file shows up. Oh, I need to be on the desktop rather than in there, so I made a mistake. We'll go and say C users Scott desktop. Look at that. There's test.txt. Let's open it up and see if it's a lie. Oh, look at that. Here's a Linux file, and then you can see down here in my Notepad application that is using the Unix line feed or the Unix line endings, which is pretty cool. That gives me a lot of flexibility. But if I go back over here to the Linux file system, can I see that file system from Windows? Well, here's some interesting things that you can do. In fact, if I make a file here like foo or test, let's go and make another one. We'll say vim my new file.txt. This is a Linux file in Linux file system. Okay, I can say notepad.exe. This gets a little confusing, so I want you to pay attention. I'm actually going to try to run a Windows executable, but I'm here on Linux. Now, of course, that won't work, but what will happen is the Windows subsystem for Linux will tell Windows, I really want you to run this, and give it the path to that Linux file. So it will, in fact, work. I can launch a Windows application from Linux. That's really Linux. It's not an emulator. It's the actual thing. Close that up. And can I access this from Explorer? Well, I could run notepad.exe. Let's try running explorer.exe. How can we access the Linux file system from Windows? Well, what we do is we use a network share. It's an automatic network share. In fact, all of the Linuxes that we're currently running get network shares, which allow us to then have Windows access Linux or Linux access Windows. We can go either way. That makes things really, really easy. But if I go and make an application, let's go and look at my own website. So this is the source code for Hanselman.com. All right. If we go up here and we go to Hanselman.com, which is my personal website, we've got my details, and you can go and learn about me there. Here's the source code for that, and I'm using .NET. If I say .NET -- version, I can see that I'm using .NET 5, and I can ask Linux which .NET. Well, that's the .NET that's inside of user bin.net. If I go over here and from PowerShell or DOS, I say where.net. That one's in C program files.net.exe. So it's a different installation of .NET. All right. And if I say -version here, I see that it's 5.0, but I did have to install that in 2 places. All right. So now, can I build this inside of Linux? I'm on Windows. Can I go and build this application? Yes, .NET is cross-platform. Then the question is, if I run it, if I say .NET run, that's going to then fire up on localhost 5000. What is localhost? Is it my local Windows machine, or is it my little Linux machine? We want people to feel like they can do development on a machine that is just one machine. So it's one computer with 2 operating systems. So if I click on this, in fact, I get a little certificate error, which is common when doing localhost work. And there I am running the local version of my own personal website compiled on Linux from Windows. Localhost is in fact a bit of a lie, and that's really, really interesting. If I go and run an application on my side called TCP View, TCP View is a utility that comes with the sysinternals parts of Windows, and I'm going to go and find out what's listening on port 5001. Now it's updating very fast here, and sometimes it does not want to pause. I am looking for, there we go, coming all the way down at the bottom here. Wait for that to paint. EUVW, where are we at, everybody? Sometimes this application is obnoxious. I am looking for the W, there it is. Windows Subsystem for Linux host listening on port 5000. So what happens is you have your Windows computer, you have your Linux virtual machine, this little utility virtual machine, and if you're application, PHP, Node, C#, whatever, decides it wants to listen on a port, it pokes a hole, and its local host becomes your Windows local host. That's really nice. That means that I can be running on Linux this application on what it thinks is port 5000, and I can access it directly from a Windows web browser, which is incredibly convenient. Being able to do that changes things a lot for people. Now, can I edit that source code? Well, we saw before that I can run notepad.exe, so perhaps I could go and open up startup.cs and I can see that source code. So that's cool. There's the source code for my website. But could I run Visual Studio Code on that? So I'm going to say not notepad and the name of a file. I'm going to say code dot, where dot is the current folder. And when I do that, I want you to look down in the corner here and note where it says WSL Ubuntu. It actually opened it in place, and it noticed that we are talking to WSL. Let me close that, and we'll show you what it looks like when you don't open it in WSL. So I'm going to just close everything. I'm going to run Visual Studio Code. You see down here in the corner, when you're just talking to Windows, that little button looks like this. If we are connected to WSL, I'm going to say code dot. Visual Studio Code will start running the Windows version of Visual Studio Code. And now look, it says opening remote. That's very interesting. Opening remote. Now, when we look at this, we are in WSL Ubuntu. So if I say file open, this file system here is the Linux file system, not the Windows one. We're actually changing the UI of Visual Studio Code and allowing people to easily open files. So I can actually edit my code and spend time around here very easily. In fact, I can even launch my .NET application directly from Visual Studio Code. So the Visual Studio Code Windows edition is spinning up just as we did at the command line, except this time it's doing it directly from the IDE or the code editor. And when I do that, look at this, we've got breakpoints. You can in fact see here the Linux file system path. So it gives you the best of all worlds. You're on Windows, which you're comfortable with. You can use Visual Studio Code, which you are comfortable with. You can do debugging, watch Windows, all the kinds of things you would expect to be able to do. You even have Git available to you. And you can do all of that inside of Visual Studio Code. And what it's doing, and why this is so interesting, is it's splitting in half. Let's talk about what I mean by that. We open up the extensions. We can see two things. Local extensions, 39, and extensions that are built inside of or running inside of WSL. The WSL right now has 6 extensions running inside it. One of them is C#. That allows me to develop on Linux without actually installing anything on the Windows machine. It gives me a lot of flexibility. So in this case here, if I start typing, let's go down here and I'll just start typing and see if I get IntelliSense. I do get a drop down showing me IntelliSense because it is Linux that's doing the work to give me IntelliSense like this. Visual Studio has split in half where there's the client front end. This is the Windows front end. And then if we go back over to Ubuntu and we type in top, or probably would be a better option would be htop. Even though I have some issues with my color, there we go, you can see that there is a Visual Studio Code server. It's splitting in half where there's a client side and a server side of Visual Studio, and it automatically updates that VS Code server. That means that the work of the compilation, the work of the IntelliSense is all happening entirely on the server side. And in this case, Visual Studio is just a friendly shell or a friendly face on top of that. One of the things we haven't yet talked about, but we should, is the relationship between WSL and Docker. We go back out of Ubuntu and we type in WSL-list-v. We can see a number of versions of Linux that are running on my machine. Right here, you see Ubuntu 18.04 is running version 2, and it's currently running. Notice here that Ubuntu 20.04 is not running, and Docker is not running. So what we're going to do is we're going to turn on Docker, and I'm going to go and open up another Ubuntu. When I return, I'm going to hit WSL-list. You can see now that Docker and Ubuntu 20 are both running. Now, Docker wants to give me the ability to talk to different containers. So if I say something like Docker images, I can get a list of containers that are available, including Kubernetes and different things that I'm currently working on. That list there, this is from Windows. I just typed Docker images from Windows. I could potentially get to if I went and I ran Ubuntu, my default Linux distribution, and I say Docker images. And in fact, I get the same thing. So Docker for Windows uses WSL2 as its back end. If I open up Docker for Windows, I'll show you the UI for this. It's pretty easy. Go here to the settings and just say resources, WSL integration, and turn on integration with my default Windows subsystem for Linux distribution. I can turn it on for them individually, or I can do it just for the one that's my default. That means that Docker engine, the one that is currently running these two Kubernetes containers, automatically does that work in WSL. This is very, very clean. So could I potentially do development inside a container? Let's look at that. Let me clear this out. And what I'm going to do is go over to the D drive. And I have a folder, I think here, the GitHub is code, that has some Go code in it. Now, I'm not a Go programmer. I'm a .NET programmer. So I don't even have Go installed. But if someone gave me this, I might want to do that development. So when you join a team and they give you a new project to work on, they might say something like, here's a Word document. You can go and list out all of the instructions that you need to do to potentially do that work, set up, install Go, et cetera, et cetera. Let's see what happens if we open this with Visual Studio Code. Open that up. Visual Studio Code says, cool, shows it to me immediately. And then it says, well, Go is not available. It's not a thing. Are you sure you want to do that? And then it says, hey, this is a dev container. It's a development container. Do you want to develop in a container? I'm going to say reopen in container. Now watch that lower left-hand side there. Oops, where did I just lost my notification. There we go. Reopen in container. Let's watch this left-hand side. So now it says opening remote like it did with WSL. And it says now opening dev container. Okay, let's take a look at the terminal. If there's any outputs or issues, looks like it just worked. Okay, so now I remember I don't have Go installed on my machine. I have 39 different local extensions here. But inside the container, I can actually install Go in the container, separate from my Windows machine. I don't have to think about my Windows machine at all right now. So when I go and do something like this, and I start typing, and I get IntelliSense, in this case, I'm getting IntelliSense for Go. Who gives me that IntelliSense? Right now, this is being given to me by the Go extension for Visual Studio running remotely for me inside of a container. That means that I could sit down and get started with a bunch of code really, really quickly. This is super powerful, and I want to showcase the fact that there is the ability to open containers remotely. There's the ability to open in WSL, and there's also the ability to open for SSH. So there's multiple ways that you can potentially do this work. And what's happening is the Visual Studio Code server has split Visual Studio in half. Right now I'm running in a container, and I can actually see the terminal here inside of VS Code, as well as the VS Code backend server that is allowing us to do what we need to do. The fact that I can onboard things really quickly, I could potentially give one of you a folder and say, open this, and it would automatically configure the containers the way that you want, install the extensions that you want, and then when you close it, the dev container goes away. Is super powerful. Additionally, if we're thinking about this in the context of the cloud, right now I have Visual Studio Code on the client, and my server is Docker or WSL or something like that. Why couldn't that server be in Azure somewhere? That's what Visual Studio Code Spaces or GitHub Code Spaces is it's splitting Visual Studio in half and letting the containers in the cloud do a bunch of the work. Pardon me. It's early there, but it's late here, my friends. So here I can listen on port 9000, and I can go and run my Go application. And just as we talked about before, where I could listen on localhost 5000, anytime someone opens up a port, let's see if localhost 9000 is available to us as developers. It is. There you go. We can talk to that port right there. Now this is Visual Studio Code, which is very easy. Some people like to use Visual Studio though. If we go to Visual Studio right now, I'm going to load that up. It'll pop up on a different monitor. And then I'm going to go and open that Hanselman homepage again on Windows. Again, the file is still on the D drive on Windows. But I might want to run this in Linux. The choices available to me about where I want to run these things are IIS Express, which is our Windows reverse proxy server, Kestrel, which is running this on Windows, and then WSL2, which would run it on Linux. Let's just triple check, confirm that I can in fact run this application on Windows. There we go. This is the no, this is not the podcast. This is the main page for the Hanselman.com. Okay. That ran on the C drive. Okay. Now I can go and pull this down, say WSL2. You look over here, it says ready to go. We'll go ahead and run it again. We're going to go and make sure that everything that needs to be set up is set up, and that you in fact have, that you in fact have a .NET installation locally there. So we'll go ahead and spin this up. Listening on port 5001, same port we were listening to before. Now I've got breakpoints and step through interactive debugging, and then I can just hit F5 multiple times. There we go. So it's a very natural experience that one has running Linux on Windows. You don't really have to think about anything because, as you can see, things like ports are automatically forwarded for you. You can get these Linuxes inside of the Windows Store. So if I go and search for Linux in the Windows Store, I've got a lot of different choices to pick from, Ubuntu and SUSE and Debian. And when these get downloaded, these are really just the tar files. They're tar files or zip files of the user mode files that they need. And they're easily removed and easily installed, which is pretty cool. In fact, there are also folks that have the ability to import or export WSL. So you can export your setup when you get it perfect, give it to a coworker or a friend, and they could go and import it. Having the ability to do all of this stuff and debug and run inside of Visual Studio is pretty sweet. I've been able also not just to be able to do that with this website in VS and VS Code, but I've been able to Dockerize it as well. So if I come down here and I look at my Hanselman its core, this is the one that I'm using for the podcast. I can go and say Docker build. That's going to then use Docker, do the building of the code inside of Docker, and then send the results to Docker, making a container out of my podcast, which I could then run somewhere. And then, of course, I'm running my tests here with run.net tests. You should see some tests that are skipped because they are either old tests or tests for Windows, and I'm on Linux now. There we go. I just passed 19 tests. Now I've got that container running and ready to go, and I can put that up into Azure, which is really, really flexible. There you go. There's the final runtime there. We're bringing in ASP.NET 5 runtime. The working directory, we copy all of our files over into there, and now I have built that. And if I say Docker images, you should see we have a lot of images here. There you go, podcast. Latest. Would I then say Docker run? Let's see if that'll run. There you go. That one's listening, I think, on port 80. Not sure if that'll work, but we can find out. I might need to change that one to run somewhere else. We'll see. Yep, I'll probably want to move that to a different port. But if I went into Docker here, actually, let me run that container again. And let's see our container in our application. There it is. Look at that. Started running. Can I stop it? Stop. There you go. Look at that. I was able to start and stop my website here running within Docker under the Windows subsystem for Linux. So you've got, let's return back to our main thing here as we get to the end here. Lots of terminals to choose from. I like the Windows terminal. Lots of shells. You've got lots of shells to choose from, including now shells from WSL. With WSL 2, you've got a utility VM. You can also use VS Code. That's using code dot to open the current folder. Then you've got WSL2 debugging in VS proper. And that's done with a Visix or an extension to Visual Studio that you can go and plug in. That's all available now. In the future, this is going to get even easier so that in the future, you'll be able to go and install WSL in one line with WSL -- install. But until then, you're going to have to do a little bit of extra work as well as a few reboots to get started. In the future, we're also going to have GUI applications, so you can run GUI apps or graphical applications for Linux on WSL, and also GPU support, so you can use your NVIDIA GPUs to do machine learning and run TensorFlow, except you'll do it from Linux side of things. All right. If you want to learn more, I encourage you to check us out on Twitter. But I want to point out also that WSL2 has some really great docs, particularly ones that compare the Windows subsystem for Linux 1 versus 2, set you up on how you can get started and where the perf issues are, including what version of Windows you're on, how you want to get full capability. Because I deploy my websites to Linux, it was really, really nice to be able to put my site on the service by which it's going to be deployed. I didn't want to have be on Windows, developing on Windows, testing on Windows, and then deploy it up to Linux and have it work differently. I wanted to test on Linux, and I wanted to run on Linux in the cloud. All right. So why don't we bring our friend Shiham back, and I know that there's going to be some questions, and we can have a little bit of a Q&A, because there's a lot of information here as we start talking about WSL, Linux, and Visual Studio.
Sure, Scott. So thanks for that amazing session. So yes, we'll move on to the Q&A sessions. So we have our friend Bala, who will be running the Q&A sessions for today. So I invite Bala to shoot the questions our audience have for today. Over to you, Bala.
Yes, I think we've got only one question. And then they would let me read out the question for you. Why would someone want to run a Linux subsystem on a Windows when Windows is good enough to run and develop applications and host applications? That's the first part of the question. And the second part is .NET much faster on Linux than on Windows?
Those are both very, very good questions, and I appreciate you asking them. So why would you want to run Linux on Windows? I think that it's fair that if you look at hosting companies in the world, Linux is cheaper to host websites on than on Windows. There's licensing reasons, but also Linux has a smaller memory footprint. So if you want a cheap host, using a Linux host is usually better. But as a Windows developer, the Windows environment is more fun, more comfortable to develop in. So I prefer to develop in Windows because I like Windows. And then I deploy to Linux because it's cheaper in Linux. I run all of my websites in Azure in Linux, and it costs me 30% less than it does on Windows. So this is about choice. It's about the ability to participate in the Linux ecosystem and not be excluded. Now, the next question I think is excellent, where they said, is .NET faster on Linux than Windows? It depends. For the most part, they are within a few percent of each other. So for example, if we go out and we search for the TechEmpower Benchmark, there's a wonderful benchmark that you can go and learn about that will tell you how fast .NET is, how fast it is as it relates to other environments and latency and things like that. And ASP.NET comes out very, very fast, but it depends on your, your operating system. We're in the top 10. Here's ASP.NET Core right there. Linux does some things faster. The file system on Linux is very, very good. Opening up ports and opening up TCP/IP ports on Linux is very good. It really depends. If you have a Windows workload, we want to make it so .NET is good on both. So I don't think it's fair to say that .NET apps are faster on Linux than Windows. I'm saying that you have choice and you can use the one that makes you happy. But for the most part, it is a true statement that Linux is cheaper than Windows for hosting. So great question. Thank you for that.
Yeah, that's the only question that we have. I think the other one is just
I do see another one at the bottom, if I may, that says that the advantage of this is to being able to parallelly work on Linux and Windows without switching over. So that's a good point as well. If we look at me on Windows here, running and developing on Windows, and then coming and split screening, and now I've got Ubuntu, I want to point out how quick that was. You saw me for the entire session moving smoothly and comfortably between Windows and Linux without any trouble. I can very crisply do that. But if I were doing this work with a virtual machine is quite a heavy thing. Virtual machines don't start up in 1 second. So the advantage is exactly what you're saying, the ability to work in parallel, but also the ability to use the operating system that you like to target the server operating system that is clearly winning in the server hosting business, which is clearly Linux, which again is a little bit cheaper. Good questions. Here's another one here, if I may. I see a question that says, can we run more than one WSL on the machine? That's a great question. If you look at my screen here, I can say WSL --list-v, V for verbose, and you can see that I've actually got 7 running, 5 real ones, and 2 are Docker. You can have as many WSLs as you have memory for. So you can absolutely run them, and you can run them side by side. So I'm going to open up Ubuntu 18.04 and Ubuntu 20.04, and I'm going to say LSB release on both of them to show you that the one on the top is Ubuntu 18.04 and the one on the bottom is 20.04. So I can test. Here's the other benefit. We have kind of two answers for 2 different questions. I can run all the different Ubuntus and I can test my app. So think about the idea that on a laptop or on a regular computer that anyone has that's a Windows computer, I can now test on N number of Linuxes and ensure that my application is going to work great on all of them. So the question about different IP addresses, if I look at my IP address on this one Linux versus my IP address on this other Linux, I don't even have ifconfig installed, so this is actually a good example where I'm going to go and use a Linux package manager to install the tool that I want and then run it. You can see here that here they are both on this iNet right there, 172.25.45.179. You could potentially change the way your networking works because it's in fact HyperV underneath. If I go over to Windows rather, you can see that the WSL gateway IP address here is .1. So yeah, if you want me to answer more questions about networking on WSL and how you can control your routes and your IP addresses, find me on Twitter and I'd be happy to answer those questions. Good stuff.
Yep. Those are the questions that we have. For those guys who were not able to follow with Scott, I think we recorded this session, so we'll be uploading that to our YouTube channel in a couple of days. And probably you could have a look at them and follow the steps and configure these things for yourselves.
Absolutely. I also want to encourage people to check out my YouTube, where I talk in a lot of detail about these things. You can go and learn about the different terminals, about different features, about Docker, about containers, about the cloud, and how to use the command line and see some of the things. So if you felt that I was going too fast, not only can you look here at the Dev Day YouTube recording of this session, but also previous sessions that I've done on my own YouTube, and please do subscribe.